Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us across the entire story of Earth, from the first trembling moment when the universe opened its eyes, all the way to the distant evening when our sun grows old and the planet we call home whispers its final breath. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly enjoy these calm explorations, and when you're ready, you're always welcome to leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a quiet joy to see all the places we gather from, each of us resting within our own small corner of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into Earth's long and remarkable history together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, unfolding the story slowly and softly. If we drift back far enough, past every star, every atom, every whisper of light, we arrive in a place where time has not yet begun. There is no sound, no darkness, no emptiness to speak of, because emptiness requires space, and space itself is not here yet. All of existence rests in a state that slips away the moment we try to describe it. In that stillness, the idea of before loses meaning. It is like standing on the edge of a dream you cannot wake into because the world that could hold you does not exist. And then, in a moment that is less like an explosion and more like a quiet opening of enormous potential, the universe begins. What follows is not a burst in the way fireworks split the sky, but a stretching, a soft unfurling. Space itself expands, carrying with it the seeds of everything that will ever be. Temperature and density are so unimaginably high at first that matter as we know it cannot exist. Instead, the universe is a glowing ocean of pure energy, so thick with light that light cannot escape. If you imagine fog so dense that a lamp buried inside it cannot shine through, then stretch that idea to a cosmic scale, you may have a faint sense of these earliest instants. As the universe expands, its temperature falls, not suddenly but steadily, like a kettle slowly taken off the heat. And with that cooling, the first tiny building blocks of matter begin to appear. Quarks, electrons, and other particles that will someday build everything from mountains to the cells in your skin. A few minutes later, a moment that feels small compared to the vast ages ahead, some of those particles bind together into the first simple nuclei. Mostly hydrogen and helium, the lightest elements. No heavy metals, no carbon or oxygen yet, only the raw ingredients, waiting for stars to form. For a long stretch after this, hundreds of thousands of years, the universe is still too hot and crowded for atoms to fully settle. Light remains trapped, bouncing endlessly within the cosmic fog. But as expansion continues, there comes a gentle turning point. Electrons slow down enough to be captured by the waiting nuclei, forming neutral atoms for the very first time. Suddenly, the fog clears. Light is released in all directions, beginning a long journey across the universe. That ancient light is still travelling today, stretched into a faint microwave glow. The afterimage of creation, a soft cosmic memory. With clarity now possible, the universe reveals its earliest patterns, tiny ripples in density, born from fluctuations so subtle they're almost like the twitch of a sleeping infant, start to matter. Gravity pulls just a little harder in some patches, gently drawing gas toward the forming knots of structure. Over millions of years, these ripples grow into vast clouds made mostly of hydrogen, sprinkled with helium. They drift and swirl, gathering mass. Gravity tugs the clouds inward, compressing them, heating their cores. Inside these collapsing clouds, the first stars awaken. They ignite quietly on cosmic scales, even if the forces involved are fierce beyond imagination. Their hearts burn hot enough to forge heavier elements from lighter ones, weaving carbon, oxygen, and other atoms that life will one day depend on. These early stars live fast and die young. When their fuel runs out, they collapse and explode, releasing their newly made elements into the surrounding space. You can picture it as a kind of cosmic gardening, stars sowing material into the galaxy, scattering seeds that will someday become planets. Across the universe, this cycle repeats. Clouds gather, stars form, heavy elements accumulate. Galaxies take shape like vast spirals, filaments, or clusters, all connected by the invisible pull of gravity. Our own galaxy forms in this era, a quiet arm of stars slowly spinning around a bright centre. And somewhere within that young galactic disk, enriched by the ashes of ancient stars, a new cloud begins to collapse. It turns into a flattened, swirling disk of gas and dust, with a growing ember at its heart. That ember will become our sun. The material around it will gather, collide and merge, eventually forming worlds. Some will be small and rocky, others large and gaseous. Some will never ignite. Others will glow faintly with heat. None of them yet hold oceans, mountains, or life. But the ingredients are there, drifting, waiting, settling. The story of Earth is poised to begin, but for now, we linger in this moment. The universe has opened, stars have lived and died, and the stardust needed to build our planet has quietly arrived in the right place. As we rest here in this early cosmic landscape, it feels almost like listening to the soft breathing of the universe itself. Everything is cooling, expanding, forming structure, preparing the long path that will eventually lead to a small blue world. And soon, from this quiet swirl of dust and light, the sun will brighten and the earth will take shape beneath it. This session gently explored the calm beginnings of the universe, using soft imagery to describe the expansion of space, the clearing of the cosmic fog, the emergence of the first stars, and the slow gathering of material that would one day form the sun and the earth, ensuring everything was explained in a smooth and restful cadence, without technical symbols or sharp transitions. As we drift further into the unfolding universe, time begins to stretch into a calmer rhythm. The earlier storms of creation have settled. Light now travels freely, carrying with it the memory of everything that has happened so far. The universe, once dense and scorching, has expanded into a vast, cooling canvas. And on this canvas, patterns begin to appear, soft at first, almost like the faint ripples spreading across a still pond when a leaf touches the surface. These ripples are gentle variations in density, left behind from the earliest trembling moments of space-time. Even though they were once smaller than anything we can meaningfully imagine, gravity slowly persuades them to grow. Regions with just a little more matter begin to gather more still, and the universe takes on a delicate web-like structure. Over millions of years, these filaments tighten their hold. Gas flows toward them, settling into knots that deepen into clouds. Each cloud is a quiet promise, a place where something new may start. Inside these giant clouds, made mostly of hydrogen with a small trace of helium, the temperature drops low enough for gas to collapse under its own weight. With gravity pulling inward and pressure pushing outward, there is a long, slow dance of forces. When the inward pull wins, the cloud begins to contract, and as it contracts, it spins. The spin flattens the cloud into a wide, thin disk, swirling around a growing bright point at the centre. These disks appear throughout the young universe, each one a cradle for a future star or cluster of stars. In that era, our own sun story begins quietly in one of these star-making nurseries. The cloud that gave rise to the sun was not a simple one. It was already enriched by the ashes of earlier stars, giant ones that had lived briefly and ended violently, scattering the heavy elements they had forged in their hearts. Those elements, carbon, oxygen, silicon, iron, accumulated over time. Without them, no solid planets could form. So in a way, before the Earth even existed, other stars lived entire lives to prepare its ingredients. Their remnants drifted through space until they finally came together in a single cloud within our galaxy, waiting for the right moment. That moment arrived when something, a distant shock wave, perhaps the dying breath of a nearby star, passed through the cloud. The disturbance caused small regions to compress, triggering a collapse. At the center of that collapsing region, heat built up. Gas spiraled inward, falling into the growing sphere of warmth. The object that formed there glowed faintly at first, not yet a true star, but more like an ember hidden within a swirling furnace. Around it, the remainder of the cloud spun into a broad disk of dust and gas. Inside that disk, millions of particles drifted like tiny grains suspended in a soft golden nebula. With every gentle collision they stuck together. Small clusters became pebbles, pebbles became stones, stones became boulders, and as these bodies grew their gravity strengthened, pulling in more material. Some of the growing clusters slammed into one another, breaking apart only to drift through the disk again and stick to something new. It was a chaotic nursery, but a productive one. Where collisions were common, worlds began to assemble grain by grain. In the warm central zone of this disk, conditions were just right for rocky planets to form. Not too cold so that water would freeze, not too hot so that everything would vaporize. Here the seeds of Earth began to gather. They did not look anything like a planet then, just clusters of rock drifting in widening spirals, occasionally meeting, merging or shattering. Over countless impacts, the early Earth grew heavier. Its gravity strengthened. It pulled in more dust and stone. Bit by bit, the young world took shape. Meanwhile, the forming sun grew brighter at its core. Pressure continued to rise as more gas fell inward. When the temperature reached the threshold needed for nuclear fusion, the star ignited fully. It wasn't a fiery flash, but a strengthening glow as the sun settled into its long, steady life. With fusion active, the sun began converting hydrogen into helium in its heart, releasing energy that radiated outward as light and warmth. This was the moment the solar system truly came alive, when the faint ember became the bright companion that would warm Earth for billions of years. As the sun ignited, the surrounding disk changed. Waves of energy and solar wind swept through it, clearing away loose gas and sculpting the remaining dust into smaller, denser rings. Young planets, including the growing Earth, continued to gather material until the disk thinned and the chaos quieted. For the first time, the solar system resembled something familiar, a glowing star at the center, and around it, young worlds following calm, predictable paths. Earth's orbit formed within what astronomers now call the habitable zone, where warmth is steady and gentle enough to allow liquid water, one of the most remarkable alignments in the entire cosmic story. Venus formed closer in, where heat would one day become overwhelming. Mars formed farther out, where cold would eventually claim its surface. But Earth's position was just right, neither scorching nor frozen. It was a quiet middle, ground in a vast unfolding system. For now, the young Earth was still only a rough and molten sphere, no oceans, no mountains, no life. But its birth had begun, crafted from dust that once drifted through ancient stars, shaped by the slow, steady pull of gravity, and warmed by the new sun. The solar system had become a stable home, and Earth was now ready for the next chapter in its long and extraordinary story. As the young sun settled into its steady glow, the newly forming planets continued to drift and collide within the thinning disk of dust around it. Among these worlds, Earth was still more an idea than a finished place, an unfinished sculpture shaped by countless impacts, each one adding new layers, new heat, and new structure. If we were to look at the planet during this stage, we would not see anything familiar. There would be no oceans, no clouds, no solid ground. Instead, Earth would appear as a shimmering sphere of molten rock, constantly reshaped by the violent rain of material falling onto it. In this early era, the solar system was far from calm. It was a place filled with debris of all sizes, from grains of dust drifting like smoke to great blocks of rock tumbling through space. Every few minutes something collided with Earth. Some impacts were small, like pebbles thrown into a pond. Others were powerful enough to melt large regions of the surface. Each collision added tremendous heat, keeping the young planet in a near-liquid state. The ground was more like a glowing ocean of magma, flowing and folding into itself. Deep inside this molten world, a quiet separation was taking place. As the planet churned, the heavy elements, iron and nickel, began to sink inward under their own weight, gathering toward the center. Meanwhile, lighter materials drifted upward, forming the early mantle and crust. We can imagine it the way ingredients settle in a pot of warm soup, dense parts falling toward the bottom, lighter parts rising. This gentle comparison hides a truth of staggering scale. The sinking metals formed Earth's core, a deep and enduring reservoir of heat that would power the magnetic field for billions of years. That magnetic field, in time, would become the invisible shield protecting the planet from the harsh breath of the sun. Above the surface, the air, if we can call it air, was a swirling, suffocating mixture of volcanic gases. There was no oxygen yet. The atmosphere was made of steam, carbon-rich gases, traces of sulfur, and other compounds rising from the restless magma. Intense heat kept much of this mixture from condensing into rain. Lightning may have flickered across the skies, slicing brief pathways through thick clouds of vapor, illuminating the young world in harsh, flickering strokes. And somewhere beneath that heavy sky, the planet continued its slow journey toward becoming something solid. But before Earth could settle, the greatest event of its early story arrived. Drifting through space was a planetary body about the size of Mars, a world we now call Theia. Its path brought it into a slow, inevitable alignment with Earth, and in the quiet emptiness of space the two bodies finally met. It was not an explosion in the usual sense. There was no sound, because sound cannot travel through a vacuum. Instead, the collision unfolded like a silent cosmic ballet. Two massive worlds merging, tearing, melting, and reshaping each other. The impact was powerful enough to melt most of Earth's outer layer again, turning rock into vapor and liquid in a sweeping flash. A great portion of the surface was thrown outward into orbit, forming a hot ring of debris circling the Earth. Over time, this material cooled, clumped together, and gathered into what would become the Moon. It is a strange poetic thought that the Moon is made from the Earth's outer layers, returned to the sky to watch over the world it once belonged to. After the collision, Earth needed time to recover. This surface remained molten, glowing like the surface of a vast furnace. Slowly, as the ages passed, heat escaped into space, and the outer layers began to cool. The first crust formed, a thin, fragile shell covering the still turbulent interior. But it would not remain peaceful for long. The planet's surface cracked, shifted, and rebuilt itself over and over. Lava fountains surged upward, spilling across the ground and hardening into new land. Entire regions cooled enough to form primitive continents, only to be broken apart again by the restless movement below. This early tectonic activity, though still simple compared to the drifting continents of the modern world, played a vital role in shaping the young planet. Through cracks in the crust, gases continued to escape, thickening the atmosphere bit by bit. Steam rose and fell, sometimes condensing for brief moments before evaporating again. The world was still too hot for steady rainfall, but the process had begun. Each day brought Earth closer to the moment when rain would finally fall and stay, filling the low places and giving rise to the first oceans. Eventually, as the surface cooled enough, water began to condense more consistently. At first it fell in bursts, short-lived showers evaporating almost as soon as they formed. But over millions of years, the planet's temperature dropped to a point where water could remain. Rain began to fall for longer stretches, sometimes for centuries at a time. With each passing storm, a little more liquid collected on the surface. Pools formed, then lakes, and finally the earliest outlines of oceans. These waters would become the cradle of life, but for now they were simply another step in the long transformation of the planet. Above these early oceans, the atmosphere remained thick and unbreathable. No oxygen yet traced the air. The sky may have glowed an unusual colour, tinted by volcanic gases. Lightning continued to flicker through the clouds, but beneath that heavy sky, the Earth was becoming something recognisable. The molten world of fire had softened into a world of rock and water. The sun's warmth, though still intense, no longer evaporated every drop. The crust grew thicker. The mantle settled into slow, deep circulation, and the core continued to generate the invisible magnetic shield that would protect the delicate chemistry yet to come. If we could stand on the cooling surface then, we would see a world still unfamiliar but full of potential. The ground beneath our feet would feel warm. The air would be thick, hot, and harsh. The horizon would hold no plants, no mountains carved by rivers, no life. Yet every element necessary for the next stages, the oceans, the stable crust, the shielding magnetic field, was now in place. The Earth had survived its most chaotic era, and an even more remarkable chapter was about to begin. The quiet arrival of life in the oceans it had just created. As Earth continued to cool and reshape itself after the Great Collision, the glowing ring of debris circling above it began its own quiet transformation. At first, the ring resembled a stream of molten beads, each fragment reflecting the newborn sun's light as it drifted through space. These fragments, made of vaporized rock and shattered crust, gradually slowed and clumped together. Tiny grains became pebbles, pebbles became boulders, and boulders gathered into larger bodies. All of it happened wordlessly, gracefully, the way dust gathering on a windowsill slowly becomes a layer without us ever seeing each particle fall. From this ring of Earth's own material, the moon began to assemble. In its earliest days, it was a world of liquid stone, glowing with heat, its entire surface a boiling ocean of magma. With time, this molten layer cooled, cracked, and solidified into the pale crust we recognize today. But the moon was not simply a byproduct of a violent collision. It would become one of the most important partners Earth could ever have. In its quiet orbit, it would guide the young planet through millions of years of change, acting as a stabilizing hand on a spinning top. When the moon was much closer than it is today, its appearance in the sky would have been overwhelming, perhaps 10 or 20 times larger than the familiar globe we see now. Its gravitational pull on Earth's surface was incredibly strong. With each orbit, it tugged on the oceans and molten regions beneath the crust, generating tides far more dramatic than the gentle rises and falls we know. These early tides likely surged across Earth's surface in enormous pulses, stirring the newly formed seas and helping shape the environments where the earliest chemistry of life would later unfold. More importantly, the Moon's presence helped stabilize Earth's axial tilt. Without this companion, Earth would wobble much more dramatically over long periods of time. Sometimes it might tilt so far that one hemisphere would remain leaned toward the sun for ages, sweltering under endless heat, while the other endured long frozen winters. Instead, because of the Moon's steady gravitational influence, Earth's tilt remains relatively gentle. Seasons come and go in a predictable pattern. Climate stays within ranges that life can adapt to. This quiet, stabilizing effect is one of the reasons Earth could become such a welcoming home. The giant collision that formed the Moon also reshaped Earth from the inside. When Theia struck, deep layers of molten rock mixed and churned, altering the structure of the planet's interior. This may have helped strengthen Earth's magnetic field, the invisible shield that protects us from solar winds, streams of charged particles that would otherwise strip away the atmosphere. Without this shield, Earth might have become barren like Mars, whose weak magnetic protection allowed the sun to slowly peel away much of its air. Thanks to that ancient impact, Earth's magnetic field grew strong, wrapping the planet in a soft protective cocoon. As millions of years passed, the Moon's orbit slowly expanded. Each month, it drifted a little farther away, an extremely gradual retreat that continues to this day. The tides grew gentler, the sky became a little more like the one we know now, and as the Moon moved outward, Earth's surface finally had the stability it needed for ocean basins to settle and continents to cool. Volcanoes still erupted, ash still filled the skies, and the atmosphere remained thick with steam, carbon dioxide, and other gases from the churning interior. But the foundations of a stable world had been set. With the Moon's gravitational influence guiding each rotation, Earth's day began to shorten. In the earliest times, Earth may have spun so quickly that a day lasted only a few hours. As tidal forces slowed this rapid spin, the day lengthened, giving the young planet a more leisurely rhythm. This slowing of Earth's rotation would one day help define the cycles of sunlight and darkness that shape the behavior of every organism. In a sense, the Moon helped carve out the tempo of life long before life itself existed. From its stable orbit, the Moon also became one of Earth's first storytellers. Its surface is covered in craters, each one marking an ancient impact that the Earth itself likely experienced too. But while Earth's surface constantly recycles itself through shifting plates, erosion, and volcanic activity, the Moon remains geologically quiet. Its craters do not fade, its scars do not heal. They remain as records of the chaotic solar system of long ago. In studying the Moon, scientists can read Earth's erased childhood, a time when impacts were frequent and the environment was harsh beyond imagination. There's a quiet poetry in knowing that the Moon is a piece of Earth. It began as part of our crust, torn away in a single silent collision, only to become the companion that watches our world from above. When ancient humans looked up and saw its pale glow, they saw something older than any story, any tool, any civilization they would ever create. They saw a witness to everything Earth had endured before life began. If we imagine standing on Earth's surface during those early ages, perhaps on one of the first pieces of solid crust to cool, the Moon would loom enormous in the sky, bright, fiery, perhaps still glowing faintly from its birth. The sky would be thick with volcanic vapours, the ground trembling with the movement of molten rock beneath the crust. Yet even in this wild alien world, the Moon would rise and set. It would pull the seas, it would keep the planet steady, It would be the first familiar shape in a world not yet ready for life. In time, the moon's presence would help create the gentle tidal zones where early life could begin. It would guide the rhythm of oceans, influence the patterns of climate, and shape the natural cycles that life would come to depend on. And through the long ages ahead, through continents shifting, creatures evolving, ice ages advancing and retreating, the moon would remain above us, a quiet companion circling endlessly, holding Earth's tilt in place and lighting the night. Now that this partnership between Earth and Moon is formed, the stage is finally set. Oceans will stabilize, atmospheres will cool, and the first fragile steps toward life will emerge in the waters shaped by these ancient tides. As Earth continued to cool after its fiery beginnings, the sky above it changed slowly from a haze of glowing vapor into a heavy, restless canopy of thick clouds. These clouds were unlike anything we know today. They were dense and dark, stretching from horizon to horizon, built from the steam and gases released by countless volcanic eruptions. The air was warm and heavy, and sunlight struggled to reach the ground through the swirling layers above. Yet, hidden within this dense veil, something essential for the future was gathering: water. For millions of years, the atmosphere held vast amounts of steam, water suspended as vapor because the surface below was still too hot for it to condense. But Earth was gradually losing heat to space, little by little. The crust thickened. The glow of molten rock faded under cooling layers, and eventually a threshold was crossed. The temperature fell just enough for the steam to begin changing form. High in the atmosphere, droplets formed, merged, and then fell. At first, the rain came in sporadic bursts. Clouds released their water only to see it evaporate again as soon as it touched the hot ground. But as cooling continued, these brief showers grew longer, and soon the sky opened in a way that had never happened before. Rain began to fall, not for hours, not for days, but for centuries, then for millennia. Imagine the steady sound of rain on a roof, stretched across ages. Imagine water pouring down from the sky for a span of time longer than human civilization has existed. That was the world Earth became, a planet wrapped in an endless storm. The rain hit the ground with tremendous force, meeting surfaces still warm enough to hiss and roar as each drop vanished into steam. But slowly the surface cooled enough for water to remain. The rain no longer vanished instantly. Instead, it collected in shallow depressions, forming the earliest pools. These pools deepened into basins, and the basins widened into immense stretches that would eventually become oceans. Water also arrived from above in a different way. In the outer reaches of the solar system, many asteroids and comets carried ice, frozen relics of the early protoplanetary disk. During Earth's chaotic youth, many of these icy wanderers struck the planet, releasing their water into the growing atmosphere. Some scientists imagine this as a cosmic delivery of ingredients, bringing additional water and enrichments like simple organic molecules. Whether these impacts provided a small share or a significant portion of Earth's water, they contributed to the world that was forming below. As rain filled the basins, the early oceans began to shape Earth's identity. Water flowed across the ground, dissolving minerals and carrying them into the deepening seas. The chemical mixture of these early waters was different from what we know today, more acidic, rich in metals, swirling with particles from the young crust. But within this environment, a new kind of chemistry was quietly beginning. Simple molecules drifted through the warm shallows, colliding and reacting in ways that would someday lead to life. The oceans became not only a physical feature of the world, but a cradle, a place where possibilities gathered. Beyond nurturing chemistry, the oceans played a crucial role in stabilizing the planet. Water has a remarkable ability to hold and distribute heat. As sunlight reached the newly formed oceans, they absorbed the warmth during the day and released it gradually at night. Instead of wild swings between scorching days and freezing nights, the temperatures began to smooth out. Storms still roared through the skies, and the atmosphere remained thick with volcanic gases, but Earth was slowly becoming more temperate. The oceans acted like a vast memory system, storing heat, balancing climates, and softening the wild nature of the young planet. Currents also began to form as water moved across the planet's surface. The early Earth spun faster than it does today, so the oceans were stirred by strong rotational forces. These movements churned nutrients from the seafloor to the surface and carried minerals from one region to another. Although there was no life yet to take advantage of these currents, they helped shape the chemical landscapes where future organisms would emerge. The oceans were not still. They were alive with motion long before they held anything living. Above the water, the atmosphere was slowly changing. Rain washed carbon-rich gases from the air into the oceans, reducing the greenhouse effect and helping temperatures continue to drop. Steam thickened into clouds, and clouds fell as rain. When volcanic eruptions sent new gases upward, they too were folded back into the water cycle. The exchange between sky and sea became one of Earth's most important processes, a continual give and take that would later support everything from weather patterns to climate systems. If we picture Earth during this era, the world would appear unfamiliar yet astonishing. Oceans covered vast areas, glinting through breaks in the cloud layers. On the surface, the water might have seemed murky, swirling with minerals and warmth. The land masses, if any solid ground yet rose above the sea, would be barren, empty plains of dark rock. The air would have been incredibly heavy, thick with volcanic vapour. But beneath this rough exterior, the conditions were growing more suitable for the delicate chemistry that life requires. Deep beneath the surface of these early oceans, hot vents spewed minerals into the surrounding water. These vents created pockets of warmth, rich in energy and chemicals that could support the first complex reactions. Some scientists imagined tiny chambers within the minerals around these vents, natural containers where molecules could gather, react and evolve toward greater complexity. Whether life eventually arose in these deep places or in the warm, shallow pools near the coasts, the ocean was preparing itself as a home for the first living things. And so, through endless rainfall, volcanic breath, and cooling stone, the oceans gathered. They spread across the planet, filling its low places, shaping its climate, sculpting its chemistry. They became the steady heartbeat of a world learning to balance itself. In their depths and along their shores, the first chapters of life would soon begin to unfold. But for now, the ocean simply existed, vast, ancient, waiting quietly for the spark that would change everything. As the ocean settled into their vast basins and the storms overhead softened from endless downpours into gentler cycles of cloud and rain, Earth entered a quieter chapter. The world was still young, still raw, and still far from anything recognizable to us. But beneath the waves, something extraordinary was beginning. The oceans, now stable and rich with minerals, had become laboratories of possibility. Warm shallows, deep volcanic vents, and shifting coastlines offered endless environments where simple molecules drifted, collided, and occasionally formed more complex structures. These early interactions were like the first tentative sketches of a story that would someday fill the entire planet. Life did not begin suddenly or dramatically. There was no single moment where a molecule declared itself alive. Instead, it emerged gradually through countless small steps, each one building on the last. Imagine tiny, delicate patterns forming in wet sand as tides come and go, always changing, always shaping, until eventually something stable appears. In a similar way, simple molecules learn to bond, break apart, and assemble again. Some combinations lasted longer than others, some made copies of themselves, even if imperfect, and over time something astonishing took root. Self-sustaining chemical systems capable of growth and replication. These earliest forms of life were nothing like the beings we know today. They were microscopic, far too small for the eye to see, and consisted of simple cells without a nucleus. They lived in environments that would be deadly to modern plants and animals, feeding on chemical gradients and mineral-rich waters. Yet these tiny pioneers were resilient. They learned to harness the energy around them, using it to build and maintain their structures, and as they multiplied, they began reshaping the world in ways that would echo across billions of years. Some of these early microbes found a remarkable way to capture energy directly from sunlight. They absorbed light and used it to drive chemical reactions, turning carbon-rich molecules into food and releasing oxygen as a byproduct. These organisms, ancient ancestors of what we now call cyanobacteria, became one of the most influential life forms in Earth's history. When they first emerged, their oxygen release went unnoticed. The oceans absorbed most of it, reacting with dissolved iron and other elements. For millions of years, the oxygen simply vanished into the surrounding waters, binding with metals and sinking to the seafloor. But the cyanobacteria kept working, tirelessly performing their quiet alchemy. Over time, the oceans could no longer swallow all the oxygen they produced. The gas began to accumulate first in pockets, and then throughout the water. Eventually, some of it reached the atmosphere, changing it forever. This slow accumulation became one of the most dramatic turning points in Earth's story. Before this transformation, the atmosphere was rich in gases that made the world warm and unbreathable. With oxygen rising, it began to shift toward something new, something that could one day support complex life. This event, often called the First Great Oxidation, unfolded quietly but profoundly. Many early organisms which had evolved in oxygen-free environments found the new atmosphere toxic. Some died out. Others retreated to places where oxygen could not reach, deep sediments, underwater vents, and oxygen-poor pockets of the ocean floor. But for the future of life, oxygen was a gift. It allowed for more efficient ways of using energy and opened pathways toward greater complexity. Without this slow atmospheric change, no animals, plants, or humans could ever have existed. During these long ages, the oceans filled with signs of microbial life. Large, layered structures known as stromatolites began to form in shallow waters. These structures were built by communities of microbes living in thin sheets, trapping grains of sediment and building them into mounds over time. Some stromatolites still form on Earth today, and though they may look like simple rocks, they are the stone diaries of ancient life, records of the earliest ecosystems that shaped the world. Within the microscopic cells themselves, a quiet revolution was unfolding. Some microbes learned to cooperate, forming partnerships that allowed them to do more together than they could alone. One of the most remarkable examples of this cooperation involved a tiny cell taking up residence inside another. Instead of being digested or destroyed, the inner cell found a new home, exchanging its energy-producing abilities for shelter. Over time, the two became inseparable. The inner partner evolved into a structure we now call a mitochondrion, the tiny engine inside almost every complex cell on Earth. This merging of two cells into one more powerful organism was one of the greatest leaps in the history of life. It allowed cells to generate far more energy than before, opening the door to larger, more complex structures. Later, a similar partnership gave rise to chloroplasts. the green structures that allow plants to turn sunlight into nourishment. These quiet mergers were acts of unity on a cellular scale, setting the stage for multicellular life. As oxygen continued to rise and cells grew in complexity, the oceans began to change colour. Iron-rich waters cleared as oxygen bound with the dissolved metals and carried them to the seafloor in rusty bands. Over countless ages, these layers formed vast deposits of iron-rich rock, a global signature of the planet learning to breathe. The sky also transformed. The oxygen in the atmosphere reacted under sunlight to create a new protective layer of gas high above the Earth. This thin shield, known today as the ozone layer, absorbed harmful ultraviolet radiation, making the surface and the shallow waters below safer for future life. Through all these changes, life remained small and simple, yet its influence spread across every corner of the ocean. Microbes adapted to boiling vents, freezing waters, acidic pools, and salty lagoons. They experimented endlessly with new metabolisms and new forms of cooperation. Their quiet persistence laid the foundation for everything to come. As this era drew on, the stage was being set for something extraordinary. With oxygen rising, energy flow improving, and protective layers forming in the sky, life was ready for a leap. Soon the oceans would see an explosion of shapes, forms, and movements. But for millions of years the story was written by microbes, patient, resilient, and endlessly creative, transforming the world grain by grain, molecule by molecule, until the planet itself began to feel alive. As the oceans continued their long and quiet transformation, the world drifted into an age where life had become more capable, more energized, and more prepared for change than ever before. The rise of oxygen had unlocked new ways to store and use energy, and the protective layer high above the planet had softened the sun's harsh, ultraviolet light. For countless ages, life had existed as simple cells, patient, adaptable, and creative in ways invisible to the naked eye. But now, with the world more stable and the oceans rich in opportunity, something remarkable was beginning to stir within those ancient seas. Life, for the first time, was ready to experiment with complexity. At first, the changes were hidden within the cells themselves. The quiet mergers of earlier ages, where one cell became a permanent guest inside another, had created an internal engine capable of producing energy with astonishing efficiency. With this new energy came the possibility of growing larger, moving more intentionally, and building structures far more elaborate than ever before. Over millions of years, small groups of cells began working together, forming early multicellular organisms. These simple colonies cooperated, divided tasks, and discovered the advantages of living as many instead of one. But cooperation was only the beginning. Beneath the surface of the oceans, genetic systems were evolving, acquiring new ways to control the growth and shape of bodies. This internal roadmap allowed organisms to branch into forms never seen before. Some cells became specialized for movement, others became internal scaffolding, some became protective shells. Slowly, gently, life began to sculpt itself into creatures with symmetry, limbs, eye spots, and digestive systems. Then, around 540 million years ago, something extraordinary happened. A burst of creativity so rapid and so diverse that the fossil record captures it like fireworks frozen in stone. Modern scientists call this event the Cambrian explosion, but the name can be misleading. It was not an explosion in the sense of noise or chaos. It was more like the sudden blooming of flowers after a long cold winter, life unfolding in shapes and colours that had never existed. In this era, the oceans became crowded with new forms. Some were delicate, floating like leaves carried by gentle currents. Others crawled along the seafloor, digging through soft sediments. Some grew shells or plates, hard outer coverings that served as protection. Eyes became more complex, allowing creatures to sense light, movement, and even shapes. Simple nervous systems expanded into networks capable of coordinating limbs and responding to the world with intention. The seas echoed with silent motion, a ballet of new bodies exploring the possibilities of form and function. Predators appeared for the first time, creatures capable of chasing, grasping, or swallowing others. Their arrival sparked an evolutionary back and forth. Prey developed thicker shells, faster movements, and better senses. Predators grew sharper appendages, improved vision, and more. Agile bodies. This gentle tug-of-war shaped the early food chains and drove further innovation. Although we picture these interactions with drama today, in the ancient oceans they unfolded quietly, instinctively, without thought or malice. Life responding to life in a delicate balance. Some of the most iconic creatures from this era include trilobites, with their segmented armour and graceful movements across the seafloor, early worm-like animals with simple digestive tracts, and strange experimental forms whose shapes have no modern equivalent. Some resembled underwater kites, some looked like spiralling ribbons, and others appeared as alien as anything imagined in science fiction. It was a time when evolution allowed itself to wander, testing ideas freely and leaving behind a fossil record full of wonders. The oceans themselves were changing too. As more complex organisms evolved, they stirred the sediments, oxygenated deeper waters, and created microhabitats across the seafloor. The presence of predators altered the behaviour of prey, shaping where they lived and how they moved. Rivers carried minerals from the early continents into the seas, feeding the growth of plankton and other microscopic life at the base of the food chain. This rich, layered complexity marked the beginning of modern ecosystems, intricate networks where each life form depended on many others. What makes the Cambrian era so astonishing is not just the number of new species, but the birth of the fundamental body plans that would shape life for hundreds of millions of years. The ancestors of arthropods, mollusks, vertebrates, and many other major groups first appeared in this period. It is as if nature drafted the outlines of nearly every creature that would ever walk, swim, or fly on Earth. Even though many Cambrian organisms vanished without descendants, the basic blueprints they introduced continue to echo in the forms of animals around us today. Scientists often describe the rise of complex life in terms of genetic innovations, systems that control when and where different body parts form. But for a gentle, sleep-friendly storytelling, these innovations can be imagined as lanterns lighting up inside the cells, allowing them to build structures in new ways. With these lanterns, life could shape itself into bodies with symmetry, limbs, heads, and tails. The diversity that followed was a celebration of possibility, each organism reflecting a different experiment in the art of being alive. Through all these transformations, the oceans remained the stage. Warm shallows teemed with algae and early animals. Deeper regions hosted strange swimmers with fins and spines. Seafloors became bustling with burrowers that churned the sediments like tiny ploughs. Light filtered through the water in shifting patterns, glinting off shells and shimmering across soft bodies. Though the world above the ocean surface was still empty and barren, the world beneath had become rich with motion and colour. The Cambrian bloom did not last forever. Over tens of millions of years, the rapid pace of innovation slowed. Many experimental forms faded into extinction. Others refined their features and continued into new eras. But the foundations had been laid. Life would never again return to the simplicity of its earlier ages. The oceans had awakened, and the planet had entered a new era of complexity, diversity, and intricate relationships. With this transformation complete, life was ready for its next great step, climbing out of the waves and discovering the land above. After the oceans awakened with the vibrant life of the Cambrian seas, Earth stood on the edge of an even greater transformation, one that would reshape the continents, alter the air, and create the landscapes we recognize today. For hundreds of millions of years, life had been an exclusively aquatic affair, confined to the comfort of salt water where nutrients drifted freely and sunlight arrived gently from above. The land, by contrast, was a barren realm, its rocky surfaces baked under intense sunlight during the day and cooled sharply at night. Without soil to hold moisture, water evaporated quickly. Without an ozone layer thick enough in earlier ages, harmful ultraviolet rays streamed down, making the land an inhospitable frontier. Yet as the ozone layer strengthened and the atmosphere stabilized, a new world began to open. Life, always curious in its quiet, tireless way, approached the edge of the sea and began to explore. The first pioneers were tiny plant-like organisms, simple green films that clung to damp shorelines, living in the delicate boundary where tides rose and fell. In these zones, life faced new challenges: dryness, gravity pressing on tissues not built to stand upright, and the need to draw nutrients from solid ground rather than water. But these pioneers also found light in abundance and vast surfaces untouched by competition. Slowly, life began to adapt. The earliest land plants were humble and small, perhaps no taller than a finger. They lacked true roots, leaves, or stems. Instead, they spread thin mats across wet ground, absorbing water directly from their surroundings. Over generations, these forms developed tiny innovations that helped them hold on to moisture. Wax-like coatings softened the harshness of the dry air. Small openings, simple pores, allowed them to exchange gases without losing precious water. These innovations, though tiny, allowed plants to slowly creep farther inland. As land plants continued to evolve, another breakthrough took shape: the development of internal channels that could transport water and nutrients. These channels acted like miniature highways running through the bodies of plants, allowing them to grow taller and reach light above their competitors. With this new ability, plants began to stretch upward. Their stems strengthened, their tissues diversified, and soon, early forests began to emerge. Dense primitive gatherings of towering ferns, spore-bearing plants, and tree-like forms with bark-like outer layers. These early forests were nothing like the modern forests we know. Many of the trees lacked leaves, instead bearing feathery fronds or spiky crowns. Their roots formed networks that stabilized soil and slowed erosion. As plants spread across the continents, they began pulling carbon-rich gases from the air and locking them into their tissues. When these plants died, they fell into swampy ground where decomposition was slow, trapping carbon deep underground. Over millions of years, these layers formed the coal beds that humans would one day discover. But the transformation plants brought to Earth was far deeper than stabilizing soil or binding atmospheric gases. As forests expanded, they pumped oxygen into the air in quantities far greater than before. The atmosphere shifted once more, becoming more breathable for future animals. Rain patterns changed as dense vegetation released water vapor into the air through tiny pores, creating humid canopies that encouraged regular rainfall. The planet cooled slightly as plants absorbed sunlight and carbon, softening climate extremes and making the land more hospitable for other forms of life. While plants were conquering the land, animals watched from the safety of water. Early arthropods, creatures with exoskeletons and jointed legs, were among the first to venture onto the shore. Some came seeking food among the primitive plants. Others adapted to breathe air, developing internal structures that could exchange gases above water. Millipede-like creatures crawled among damp leaf litter. Early scorpions and their relatives hunted insects in the shadows. The land was beginning to hum with life, though slowly and cautiously at first. And then came one of the most important transitions in the history of Earth. Vertebrates, animals with internal skeletons, began to step onto land. Their ancestors were lobe-finned fish with sturdy bones in their fins, adapted originally for navigating shallow waters choked with vegetation. Over time, these fins strengthened into limbs, capable of supporting weight outside water. Their lungs, once supplemental, became primary. Their eyes adapted to the brightness of the land, and their sensory systems shifted to detect vibrations in air rather than water. The first tetrapods, four-limbed creatures, waded onto shores and ventured into forests. As plants spread, they altered the land so deeply that the continents themselves changed colour. What had once been dry, rocky expanses became tapestries of green. Mosses softened stone. Roots cracked rocks into soil. Rivers meandered more slowly through vegetated landscapes. The first true soils formed from the mixing of mineral particles and decaying plant matter, creating dark, rich layers capable of sustaining even more diverse plant life. These changes echoed across the planet. Oxygen levels continued to rise, creating atmospheric conditions that supported larger and more active animals. Inland ecosystems developed complexity. Predator and prey, herbivore and plant, decomposer and nutrient cycle. Forests harboured insects, amphibians and early reptiles. Swamps buzzed with life. Deserts began to form where rainfall was sparse, offering new challenges and new opportunities. Life's conquest of land was not a single moment but a long, unfolding story. Each small adaptation opened a pathway for others. Plants made shade and soil. Animals followed. Plants grew taller. Animals grew larger. Streams carved new paths around root systems. Winds carried spores and seeds across continents. Over time, the green mantle covering the Earth stretched across vast territories, transforming the world's climate, chemistry, and appearance. If we could stand on such a continent billions of years ago, we would see a landscape both alien and strangely familiar. Towering plants would sway without leaves as we know them. Giant arthropods might crawl along the forest floor. Amphibian-like creatures would move between ponds and mossy banks. The air would smell of damp earth and ancient ferns. Though different in detail, the sense of a living land, a breathing, growing, transforming planet, would feel unmistakable. This gentle greening of earth set the stage for the rise of great forests, enormous creatures, and new ecosystems that would soon dominate the land. The continents had awakened, and from this awakening life would continue to expand, diversify, and reshape the world in ways both beautiful and unexpected. As Earth's continents grew lush with greenery and the planet settled into a more breathable rhythm, life was drawn to the land with increasing curiosity. Plants had changed everything, softening harsh sunlight, enriching the atmosphere and creating shelter and food where once there had been only barren rock. The land had become a landscape of opportunity, new spaces to explore, new niches to fill, and new challenges to overcome. And gradually, the creatures of the oceans began to answer this call. The first explorers were not dramatic or enormous. They were small arthropods, creatures with exoskeletons, jointed legs, and bodies segmented like delicate armour. Their ancestors had scuttled along the seafloor for hundreds of millions of years, scraping food from sediments and dodging predators with swift, precise movements. For these early pioneers, the shoreline offered both risk and promise. Moist surfaces allowed them to breathe through structures adapted originally for underwater life, and the green mats of early plants provided nourishment. Slowly, tentatively, they began to spend more time on land. As these creatures ventured farther inland, their bodies began to change. Their shells thickened slightly to prevent drying. Their limbs strengthened to better handle gravity. Some species developed new ways to breathe, adapting their gills into air-breathing passages. These early land arthropods included millipedes, centipedes, primitive insects, and creatures that resembled scorpions. They wandered through the damp shadows of early forests, thriving in the cool moisture that collected beneath dense vegetation. But the most profound transition was still to come. Among the fish living in shallow coastal waters were species with unusually strong, fleshy fins supported by robust bones. These lobe-finned fish had evolved in tangled riverbeds and swampy shallows, where swimming alone wasn't always enough. They pushed themselves through vegetation-choked waters, using their fins almost like limbs to haul themselves from place to place. Over generations, these fins strengthened further, and their bodies developed features that allowed them to lift themselves briefly out of the water. In these transitional species, lungs played a crucial role. Many early fish already had simple air-filled sacs that acted as supplemental breathing organs. In oxygen-poor waters, these sacs offered a way to gulp air and survive. Over time, natural pressures favoured those who could use these organs more efficiently. The sacs gradually became more complex, evolving into true lungs capable of supporting life on land. These adaptations form the foundation for some of the most important creatures in Earth's story, the first tetrapods. Tetrapods, four-limbed vertebrates, took their first steps onto land roughly 370 million years ago. Their movements were awkward at first, more like crawling than walking. The bones in their limbs were still arranged in a pattern that reflected their aquatic origins. But even these early attempts opened pathways for future generations. With each improvement, tetrapods grew more confident, spending more time on land. Their eyes adapted to see better in air. Their skin thickened to retain moisture. Their senses shifted as sound began to travel differently through air than through water. Bit by bit, they became creatures of two worlds. In the forest that plants had created, these early tetrapods found insects to feed on, shallow ponds for laying eggs, and shaded shelters that protected them from the harshest daylight. Their bodies remained tied to the water. They still needed moist environments to reproduce, as their eggs lacked protective shells. But their growing independence from the sea marked one of the most defining chapters in the history of life. These early walkers would one day give rise to amphibians, reptiles, birds, and mammals. Every creature with limbs, every dog, every bird, every human, carries within its bones the memory of those first cautious steps onto land. As the continents continued to change, new habitats emerged. Large river systems formed, carving gentle curves across the land. Wetlands expanded, providing ideal environments for amphibians. Over time, some tetrapods adapted further, developing eggs that could survive outside water. These special eggs, protected by sturdy outer layers, contained everything the growing embryo needed: food, moisture, and a safe chamber to develop. With this innovation, vertebrates were no longer tied to ponds and swamps. They could explore dry regions and colonize forests, plains, and deserts. These creatures became the first reptiles, animals truly at home on land. With reptiles came a new stability in life's conquest of the continents. Their tougher skin prevented drying. Their lungs delivered oxygen without the need for moist environments. Their eggs could be laid in hidden nests on land. They spread across the continents, filling ecological roles as hunters and scavengers. Meanwhile, plants continued to evolve, producing seeds that could travel across wind and water. Forests grew thicker. Insects diversified in response to new food sources. The world became rich with interactions that created delicate, intertwined ecosystems. As life expanded, Earth's landscapes transformed even further. Roots dug deeper, breaking down rock into soil. Streams shifted paths as vegetation slowed erosion. Mountains weathered more gently under the influence of plant life. Forests created shade, affecting temperature and rainfall. The land and its living creatures shaped each other in a continuous exchange, each influencing the other's evolution in subtle and profound ways. If we could walk through one of these early forests, it would feel both familiar and strange. Towering tree-like plants would loom overhead, but many would bear no leaves as we know them. Instead, fronds and spirals would stretch from their trunks. Insects would buzz among the foliage, wingless forms at first, then eventually early flyers gliding from branch to branch. Amphibians, their bodies glistening in the damp, would lurk near pools and streams. Reptile-like creatures might bask on sunlit rocks, warming their bodies before slipping into the undergrowth. The air would hum with the soft sounds of a landscape not yet dominated by birdsong or mammalian footsteps, but already alive with possibility. The movement of animals onto land set the stage for dramatic future chapters. The reign of massive reptiles, the evolution of mammals, and the rise of entire ecosystems that would one day host forests, deserts, and plains. The land was no longer an empty canvas. It had become a vibrant and dynamic stage, full of life creeping, climbing, and walking through the continents. The world was changing, and with every step taken by those early creatures, Earth moved closer to the rich and diverse planet we know today. As life continued to shape the land and oceans, the Earth drifted into another vast chapter, one filled with warmth, forests stretching across continents, and creatures so large and wondrous that their shadows would echo through imagination long after they vanished. This era, known to us as the Age of Dinosaurs, unfolded over more than 160 million years, a span so long that even entire mountain ranges rose and eroded while these creatures walked the Earth. It was a world of shifting continents, changing climates, and evolving giants. Long before the dinosaurs appeared, Earth had endured the greatest mass extinction in its history. Nearly all species vanished in a sweeping global crisis that reset the balance of life. When the world slowly recovered, empty ecological spaces stood waiting like open rooms in a vast and silent building. Into these spaces stepped the ancestors of dinosaurs, small, lightly built creatures that at first seemed unremarkable. But as the environment stabilized, these early forms began to diversify. With time, they would grow into some of the largest and most graceful beings the planet had ever known. The continents of this era were not scattered as they are today. Instead, they were joined together in a single supercontinent, a massive landmass stretching across much of the globe. Warm winds swept across its interior. Seasonal rains nourished dense forests. Rivers carved winding paths through broad plains. Over millions of years, this supercontinent began to split apart, slowly drifting into separate pieces. These drifting plates reshaped coastlines and created new environments for life to explore, from humid jungles to wide deserts and coastal wetlands. As the continents moved, climate patterns shifted. Regions that were once near the poles drifted toward the equator and warmed. Others slowly cooled. These gradual changes encouraged new adaptations, new species, and a rich variety of dinosaurs. Some evolved into towering plant eaters with necks that stretched like living cranes toward the treetops. Others remained small and agile, darting through undergrowth in search of insects or fruit. Some became powerful predators, moving gracefully through forests or across open plains with sharp senses and quick reflexes. The diversity of dinosaur life was astonishing. In warm forests, massive long-necked sauropods roamed in slow, deliberate herds. Their footsteps left deep impressions in the soft soil, and their long tails swept gently behind them like drifting banners. In coastal wetlands, armoured dinosaurs grazed on low vegetation, their bodies covered with plates and spikes that gleamed softly under the sun. In other regions, swift hunters moved like shadows, feathered limbs tucked close, eyes scanning for the faintest sign of prey. Though often imagined as cold and reptilian, many dinosaurs were likely warm-blooded, active and fast-moving, more like birds than lizards. Speaking of birds, their story quietly began in this era. Some small dinosaurs developed feathers, not initially for flying, but for warmth, display, or camouflage. Over time, these feathers grew longer and more specialized. Wings formed. Light, hollow bones evolved to reduce weight. And in the branches of ancient forests or the edges of cliffs, some creatures took their first glides, then their first true flights. These early birds were not identical to the ones we know today, but they carried the unmistakable seed of the skies within them. In a very real sense, when a bird spreads its wings today, it is a living dinosaur greeting the air. While dinosaurs shaped life on land, the seas and skies also flourished. Marine reptiles, distinct from dinosaurs, filled the oceans with sleek, powerful swimmers that glided through ancient waters. In the skies, giant flying reptiles soared with wingspans wider than a person is tall, catching warm air rising from sunlit plains. All around, life experimented with form and motion, creating a world full of movement and colour. During the later stages of this era, an entirely new subset of plants began to appear: flowering plants. Before this time, plant life had been dominated by ferns, conifers, and seed-bearing structures that relied on wind to spread pollen. Flowering plants changed everything. They introduced new shapes, new scents, and new ways of reproducing. Their fruits provided rich nourishment for animals. Their flowers attracted insects, forming intricate partnerships that helped both thrive. Forests grew more vibrant, landscapes changed, food chains shifted to incorporate these new sources of energy. The world felt younger and more dynamic than ever. Yet even in this thriving world, change was gathering quietly in distant space. A small object, an asteroid drifting along its own lonely path, was moving toward Earth. For millions of years, the dinosaurs lived their lives unaware of this slow, inevitable approach. And then, around 66 million years ago, the asteroid reached Earth's atmosphere. What followed was swift. The object struck near what is now the Yucatan Peninsula, releasing an immense wave of energy. The event did not roar through the air because in truth no single moment defines it. It unfolded over days, months and years, dust rising into the sky, sunlight dimming, temperatures falling. The world entered a long twilight. Plants struggled without enough light to grow. Herbivores suffered. Predators followed. Forests changed. Oceans cooled. It was not a single blow that ended the age of dinosaurs, but a long gradual unravelling of the ecosystems they needed. Some species survived those dark years, birds among them, but many others faded into memory, leaving only fossils to whisper their shapes. When light slowly returned and the earth warmed again, the world was different. The era of giants had ended, but life, as always, found ways to continue. In the quiet spaces left behind, other creatures began to rise, and among them were the small, alert, warm-blooded animals who had spent the age of dinosaurs living mostly in the shadows. Their moment was about to begin. When the long twilight following the asteroid's arrival finally began to lift, the world opened its eyes to a quieter Earth. The age of giants had faded. Forests were thinner, climates were shifting, and many of the creatures that once dominated land and sky had vanished. But in the soft spaces left behind, where sunlight now seeped gently through recovering canopies, a new cast of life began to emerge. Small, warm-bodied, and watchful. These were the mammals, creatures that had long survived by keeping to the edges of the ancient world, waiting for their time. For millions of years, mammals had lived in the shadows of dinosaurs. They were mostly small, often no bigger than a mouse or a raccoon, alert at night when the giants slept. They survived by being quick, resourceful, and adaptable. Their bodies were covered in fur, a soft layer that helped them stay warm and active even in the cool darkness. They fed on insects, seeds, fruits, and sometimes even the eggs of larger creatures. Their senses evolved to detect danger, sharp hearing, sensitive whiskers, and noses capable of reading the world through scent alone. These humble traits, once simply strategies for survival, soon became the foundation for a dramatic rise. As life recovered from the Great Extinction, ecosystems reshaped themselves like forests regrowing after a clearing. New plants spread across open ground, insects rebounded, rivers and lakes settled into new paths. The world no longer belonged to towering reptiles. It had become a mosaic of habitats where speed, agility, and warm-blooded endurance mattered more. Mammals, with their ability to regulate body temperature and remain active for long stretches, thrived in this new world. At first, their growth was quiet. They expanded into forests, grasslands, and wetlands, filling small niches left behind by vanished species. But as time passed, these small mammals began to experiment with new forms. Some grew larger, taking advantage of abundant vegetation. Others became swift runners on open plains. Still others returned to the water, evolving streamlined bodies and powerful tails that would one day become the shapes of dolphins and whales. Mammals spread into deserts, mountains, and even underground tunnels. The range of sizes and lifestyles widened dramatically, from tiny shrews gliding through leaf litter to enormous herbivores roaming vast plains. One of the key reasons mammals were so successful lay in their biology. They fed their young with milk, allowing newborns to grow safely under the care of their parents. This created strong bonds and new social structures unseen in many other groups of animals. Their warm-blooded nature helped them withstand cold nights and harsh winters, allowing them to expand into climates where reptiles could not flourish as easily. Their brains, already more complex than those of many earlier creatures, grew even more intricate, enabling flexible behavior and problem-solving. Among mammals, one particular branch developed traits that would ultimately lead to us, the primates. They began as small, tree-dwelling creatures with grasping hands and feet, an ability that allowed them to move effortlessly among branches, picking fruit and avoiding ground predators. Their eyes shifted toward the front of their faces, granting them depth perception, a useful skill for navigating forest canopies. Their brains grew larger relative to their bodies, making room for more advanced learning, memory, and social interactions. As the continents continued to drift and climates changed, primates evolved into many diverse forms. Some remained in the trees, developing long limbs for swinging between branches. Others descended to the forest floor, learning to walk, leap, or run. Over millions of years, new shapes appeared, some with long arms adapted for brachiation, others with short limbs for careful climbing. These early primates lived in groups, communicating with calls, gestures, and expressions that hinted at deeper social complexity. Climate shifts played a significant role in shaping their journey. Forests expanded and contracted as temperatures rose and fell, forcing primates to adapt or migrate. In some regions, when forests thinned into open grasslands, certain primates began to walk more upright, freeing their hands and opening new possibilities for tool use. But that part of the story, the human part, still lay far ahead. Meanwhile, other mammal groups flourished in equally remarkable ways. Large grazing mammals appeared, feeding on the grasses that spread across cooling continents. Predatory mammals evolved speed and coordinated hunting strategies. Mammals that lived in cold environments grew thick fur, layers of fat, and clever behaviours for staying warm. Some animals developed hooves for long-distance travel. Others grew tusks, horns, or antlers for defence or display. The variety of mammalian life mirrored the Cambrian bloom in spirit, an explosion of form and function tailored to new landscapes. In the oceans, the descendants of land mammals evolved into graceful swimmers, their forelimbs reshaped into flippers, their noses migrated to the tops of their heads, and their bodies lengthened for efficient movement through water. Whales and dolphins, though often mistaken for fish-like creatures, carried within their bones the unmistakable signatures of land-dwelling ancestors. Their rise shows the remarkable adaptability of mammals, capable of returning to the sea after millions of years on land. Birds, the descendants of small feathered dinosaurs, shared the skies with flying mammals such as early bats. Forest canopies filled with movement, wings fluttering between branches, calls echoing through humid air, animals leaping from tree to tree. The world had become a vibrant tapestry of interwoven life, with mammals taking roles once held by ancient reptiles. If we could walk through this early mammalian world, we would see creatures both familiar and unfamiliar. Herds of early hoofed animals might graze across rolling plains. Small primates would leap through branches overhead, chirping and calling to one another. Strange saber-toothed hunters would stalk forest edges, their long canine teeth gleaming softly in scattered sunlight. The air would be alive with scent, sound, and movement, a world dynamic and full of promise. In these diverse environments, the seeds of future species were being planted quietly. The features that would eventually define humans, upright posture, nimble hands, curious minds, were beginning to take shape, though in subtle ways. As the world continued to cool and shift toward new climatic patterns, the stage was being set for the next great transformation, the arrival of ice, and with it, the shaping of landscapes and the further evolution of life. As Earth moved deeper into the later chapters of its long story, the planet entered a rhythm of cooling and warming that would carve the continents into the shapes we recognize today. These cycles, unfolding over millions of years, brought with them vast sheets of ice that advanced and retreated like slow, shimmering tides. Though we often imagine ice ages as moments of unbroken cold, they were in truth a long sequence of pulses, cold periods followed by gentler interludes, each one sculpting the world in patient, deliberate strokes. The beginning of these cycles can be traced to subtle shifts in Earth's orbit, its tilt, and the gentle wobble of its axis. These changes, though small, influenced how sunlight reached different parts of the planet. When conditions aligned just so, winters grew colder, snow accumulated, and the growing weight of frozen layers compressed into great glaciers. Over time, these glaciers spread across the landscape, covering mountains, forests, and plains alike. Some grew to be miles thick, massive rivers of ice creeping forward inch by inch, their movement so slow that a lifetime would pass without noticing even a single step. Yet the influence of these glaciers was anything but small. As they advanced, they carved deep valleys into the bedrock, shaping the land with a power that quieted everything in their path. Mountains were ground down, leaving behind sweeping curves rather than jagged peaks. Wide U-shaped valleys emerged where sharp, river-carved V-shaped ones had once existed. When the ice retreated, it left behind lakes, waterfalls, and rounded hills. Landscapes that today feel serene and ancient, as though sculpted by gentle, unhurried hands. Fjords formed along coastlines as glaciers carved deep grooves into the rock, allowing the sea to flood inland when the ice melted. Vast basins became homes to lakes so large they would later shape human civilizations. Even the soil was transformed. As glaciers retreated, they scattered rich sediments across the ground, layers of ground rock and minerals that would one day feed forests, grasslands, and fields of crops. During these icy pulses, the world looked very different from the one we know. Massive sheets of white extended from the poles, reflecting sunlight and cooling the planet further. In the regions between ice and warmth, vast stretches of grassland and tundra formed. These open environments supported enormous animals, megafauna, that adapted to the cold with thick fur, powerful limbs, and robust bodies. Woolly mammoths roamed across the steppe, using their long, curved tusks to sweep aside snow in search of grasses. Woolly rhinoceroses stood broad and sturdy, their coats rippling in the wind as they grazed. Giant ground sloths moved through southern landscapes, their slow, deliberate steps carrying them through forests that were shifting with each cycle of warming and cooling. Saber-toothed cats prowled across plains, their long canines glinting softly as they hunted. These were the giants of the Ice Ages, creatures shaped by hardship, endurance, and the cold breath of the world. But life was not only about the giants. Humans, too, were deeply influenced by the ebb and flow of ice. Early members of our lineage adapted to colder climates by mastering fire, crafting clothing, and building shelters from bone, wood, and hide. Fire provided warmth, protection, and a place to gather, its glow reflecting in the eyes of our ancestors as stories, knowledge, and guidance were passed down. With each ice surge, human groups migrated, following herds across open plains or retreating to warmer refuges when cold grew too intense. The shifting of ice carved new pathways across continents. When sea levels fell during glacial periods, land bridges emerged, temporary connections between continents that allowed humans and animals to travel to new lands. One of the most significant of these connections formed where Siberia and Alaska nearly touched, opening a path into the Americas. It was through these icy corridors that early humans crossed into new worlds, carrying tools, languages, and dreams with them. The ice guided them like a quiet, invisible force, shaping the destiny of human cultures long before writing or civilization existed. As climates warmed again, the ice retreated, leaving behind fertile lands softened by minerals. Forests spread northward. Rivers found new paths, fed by glacial meltwater. Animals adapted once more, with some species flourishing in the warmer environment. Others, especially the great megafauna, struggled as their habitats shrank. Many eventually disappeared, a loss shaped by climate change and, later, the growing impact of human hunters. Even after several cycles, the effects of the ice ages continue to echo across the planet. The landscapes we travel through today, the valleys, lakes, rolling plains, and familiar mountain shapes, are the lasting imprints of these frozen eras. The places where cities stand, where rivers flow, and where farms stretch across the horizon all owe something to the slow, steady hand of ice. To imagine Earth during one of these icy periods is to picture a world both harsh and beautiful. Dawn would break over frozen expanses, casting soft pink light across walls of ice. Herds of mammoths would move like shadows on the horizon. Early humans, wrapped in furs and guided by intuition and shared wisdom, would track animals across snow that glittered under a low winter sun. The world felt vast and quiet, shaped by forces too slow to see but too powerful to escape. These cycles of ice and warmth continued for millions of years, each one carving the land a little deeper and guiding life in subtle ways. The Ice Ages did not just sculpt Earth, they shaped the creatures that lived upon it, including humans. The endurance, creativity, and adaptability of early human groups grew from these challenges, setting the stage for everything that would come next. As the last great sheets of ice finally began to retreat for good, Earth entered a relatively stable climate, one gentle enough to support something entirely new: the rise of agriculture, settlements, and the first sparks of civilization. When the great glaciers were still advancing and retreating across the continents, life was already crafting a new kind of creature, one defined not by size or strength, but by curiosity, adaptability, and a spark of imagination that would someday reshape the world. This was the lineage that would lead to humans, a story that began not with sudden leaps, but with countless quiet steps taken across ancient African landscapes. Long before tools, before language, before memory was recorded in symbols or sound, early ancestors walked through forests and grasslands, slowly learning what it meant to be upright. In those early days, the world they inhabited shifted often. Forests expanded and contracted as climate changed. Grasslands opened under bright sunlight. Rivers carved fresh paths into the land. Amid these shifting environments, some primates began to explore new ways of moving. Over time, walking on two legs became an advantage, freeing their hands, allowing them to carry food, young, and eventually tools. Their spines reshaped, their hips broadened, their feet became arched for better balance. These changes happened gradually, generation by generation, until upright walking became a defining trait of the hominin line. Once their hands were free, new possibilities emerged. With more dexterity came experimentation, picking up stones, breaking them against one another, and discovering sharp edges that could cut hide or crack open marrow-rich bones. The first tools were simple, rough, and shaped more by accident than intention. But the moment a hominin realized that a stone could be used to make life easier, something profound shifted. A relationship formed between mind and material, between intention and object. This connection would only grow stronger with time. As these early ancestors roamed across Africa, their brains grew in size and complexity. This growth wasn't a sudden event, but a slow unfurling, fueled by improved nutrition, cooperation, and the challenges of surviving in ever-changing environments. Fire became one of their greatest allies. At first, it was likely borrowed from nature, from lightning strikes igniting dry grasslands or lava flows sparking small blazes. Over generations, hominins learned to tend fire to keep embers alive and eventually to create flames intentionally. Fire warmed the nights, keeping predators at a distance and allowing groups to gather in safety. It softened food, making it easier to chew and digest, providing more energy for the growing brain. Firelight also extended the day, creating time for shared stories, planning, and social bonding. In those quiet circles around glowing embers, the roots of human culture began to take hold. As millennia passed, a new species emerged within the hominin line. One of the most remarkable was Homo erectus, tall, long-legged, and built for endurance. These early humans were explorers at heart. They walked out of Africa and into new lands, crossing deserts, mountains, and forests. Their footprints have been found across Asia and Europe, a testament to their adaptability and resilience. They mastered more refined tools, hunted cooperatively, and learned to thrive in climates far cooler than their ancestral home. Meanwhile, other branches of the human family evolved in parallel. Neanderthals lived in the colder regions of Europe and Western Asia. Their bodies were stocky and strong, adapted to retain heat. They crafted tools with remarkable precision, made clothing from animal hides, and built shelters to protect against harsh winters. They buried their dead with care, suggesting emotional depth and cultural complexity. Farther east, another group, now known as Denisovans, lived in high mountain regions, adapting to thin air and cold temperatures. Though we know little about their culture, traces of their DNA survive in some modern human populations, a quiet reminder of ancient encounters. Back in Africa, another transformation was taking shape. Homo sapiens, the species to which we belong, emerged with a blend of traits that would set us apart: flexible thinking, symbolic expression, and an imagination capable of seeing beyond the immediate world. Their tools became more varied, crafted not only for function but also with hints of artistry. They decorated their bodies with pigments, carved shapes into bone, and etched patterns onto cave walls. These early artworks were not just decorations, they were signs of abstract thought, evidence that humans had begun to express their inner worlds. Language, too, blossomed during this time. It may have started as simple calls and gestures, slowly evolving into a shared system that allowed for storytelling, teaching, and cooperation on a scale unmatched by any other species. With language came memory passed across generations, not just through instinct or imitation, but through words, ideas, and shared understanding. This ability to exchange knowledge allowed humans to adapt faster than any genetic evolution could provide. As climates shifted and the ice ages advanced, humans followed rivers, coastlines, and animal herds into new regions. They crossed land bridges that existed only temporarily, expanded into deserts and highlands, and eventually spread across all continents except Antarctica. Each environment required new strategies, new tools, and new social systems. Yet everywhere they went, humans carried with them the sparks of creativity and cooperation. They formed communities, developed traditions, and learned to read the land with astonishing insight. Early humans built shelters from stone, bone, and wood. They crafted spears, bows, and nets. They learned to fish, hunt, gather, and store food. They observed the stars, traced the paths of animals, and identified the changing seasons. Their societies grew increasingly complex, bound by shared rituals, responsibilities, and stories. And though they faced challenges, from predators to harsh winters to scarcity, they adapted again and again. By the time the last great sheets of ice began to retreat, humans had spread across the globe, bringing with them not only their tools but the first seeds of culture, art, and shared identity. The world was no longer just a place to survive. It had become a place to shape, to understand, and eventually to transform. The long human journey, from upright walkers to symbolic thinkers, had set the stage for a revolutionary shift. As climates continued to warm and stabilize, something extraordinary would follow: the birth of agriculture, settlements, and the first civilizations that would rise from the fertile ground shaped by glacial hands. As the last great sheets of ice retreated, and climates around the world settled into gentler patterns, humans found themselves living in a transformed landscape. The warming earth offered richer plant life, more predictable seasons, and rivers that swelled and receded with familiar rhythms. Grasslands expanded, forests matured. And for the first time in hundreds of thousands of years, the world began to feel stable enough for something remarkable to unfold: an entirely new relationship between humans and the land. Before agriculture, humans lived as wanderers, moving with the seasons and following the migrations of animals. They knew the land intimately, where fruits ripened, where herds paused to graze, when streams ran high and when they ran low. Life depended on careful observation, cooperation, and an ability to read nature's signals. But stability invited experimentation. In certain fertile areas, humans noticed that grains dropped near campgrounds sprouted again the following year. They saw that tending patches of land, pulling weeds, spreading seeds, made food more abundant. Over generations, small acts of tending became deep acts of cultivation. Agriculture did not begin all at once or in one place. Instead, it emerged slowly and independently across several regions. In the valleys of the Middle East, people learned to plant wheat and barley. Farther east, rice took root along riverbanks and flooded fields. In the Americas, maize, squash, and beans were nurtured into dependable crops. In Africa, sorghum and millet became staples, while in the Andes, potatoes and quinoa sustained growing communities. Each region cultivated plants that fit its climate, its soil, and its people's needs. With the ability to grow food came the possibility of staying in one place. Camps became villages, clusters of homes built from stone, clay, and reeds. Families stored grain for difficult seasons. People began to specialize. Some farmed, others crafted tools, baskets, or clothing. Still others learned to shape clay into pots that held water or cooked food. Domestic animals joined these settlements: goats, sheep, cattle, pigs, each one adding stability and resilience to daily life. These animals offered milk, meat, wool, and companionship, forming a bond between humans and creatures that had once been wild neighbours. As villages prospered, populations grew. Larger communities formed near rivers, where fertile soil and reliable water created ideal conditions for farming. Over time, these communities expanded into early towns. People built walls for protection, dug irrigation channels to guide river water into fields, and created storage buildings for harvests. With these changes came new forms of leadership. Decisions about planting, water usage, and trade required cooperation and coordination. Rules emerged, traditions took root, and slowly, societies became more structured. Writing is one of the most profound legacies of these early civilizations. In Mesopotamia, marks pressed into clay tablets kept track of grain, livestock, and trade. In Egypt, symbols drawn on papyrus recorded stories, rituals, and the passage of kings. Along the Indus River, seals carried intricate designs that likely represented ownership or identity. In China, early characters carved into bone and shell were used for divination, capturing questions and hopes for the future. Writing allowed knowledge to outlive its keepers. Lessons about harvests, construction, astronomy, and governance could be passed down across generations. With stability came art, architecture, and spirituality. People built temples to honor forces they believed shaped their world: sun, rain, fertility, and storms. They carved statues, painted pottery, and wove cloth with intricate patterns that reflected culture and identity. Music and dance expressed stories of creation, harvest, and community. And as societies grew more complex, so did interactions with the land. Fields expanded, forests were cleared. Irrigation systems diverted rivers into channels that snaked across plains. While these innovations supported growing populations, they also brought challenges. Soil became tired from repeated planting. Overgrazing by livestock eroded the land. Water usage had to be planned carefully to avoid salinization, the buildup of minerals that made fields less fertile. Even in these earlier civilizations, humans learned that working against nature carried consequences, while working with nature demanded patience and restraint. Some civilizations developed remarkable solutions. Ancient farmers in Mesoamerica practiced a method called intercropping, planting maize, beans, and squash together, so each plant supported the others. beans restored nutrients to the soil, maize created shade, and squash covered the ground, reducing weeds. In the Andes, terraces built along mountainsides prevented erosion and allowed crops to grow at different elevations. In ancient China, sophisticated irrigation and crop rotation techniques maintained soil fertility for thousands of years. These innovations showed a profound understanding of ecosystems long before the modern term existed. Yet as societies expanded, differences in wealth and power emerged. Some people controlled large tracts of land or managed food storage. Others constructed monuments or served rulers. Cities rose along major rivers: Uruk, Thebes, Mohenjo-daro, Anyang, each one humming with life and trade. Merchants travelled along early trade routes, exchanging goods, ideas and technologies across great distances. Bronze tools and weapons appeared, enhancing both agriculture and warfare. Trade brought spices, precious metals, stones and stories from faraway lands. As civilizations grew, they shaped landscapes on unprecedented scales. Rivers were redirected, marshlands were drained, hillsides were sculpted into terraces, entire forests were cleared for farmland. Though these changes supported growing populations, they also altered ecosystems permanently. Species migrated, disappeared, or adapted to new human-shaped environments. Climate patterns shifted in some regions due to large changes in vegetation. Despite these challenges, the agricultural revolution marked one of humanity's most transformative chapters. It brought stability where once there had been constant movement. It allowed for surplus community, culture, and the first steps toward the complex, interconnected world we live in today. But it also demanded responsibility, a lesson civilizations would learn again and again as they grew. If we could walk through one of these early cities, we would hear the sounds of daily life. Water flowing through irrigation ditches, voices calling out in marketplaces, clay being shaped on wheels, livestock bleating in pens, and children laughing as they ran through narrow streets. Fires crackled under cooking pots. Tools clinked in workshops. Temples stood tall, their walls painted with symbols of gods, harvests, and celestial patterns. Even in these early days, the rhythms of human civilization were rich and layered. This new relationship with the land, rooted in seed, soil, and settlement, set the stage for everything that followed. From these first villages and towns would rise empires, innovations, conflicts, and breathtaking achievements. And with each new step, humans would continue to reshape their world, for better and for worse, as they moved deeper into the story of civilization. As the ancient cities grew into empires and generations shaped the land with fields, canals, roads, and temples, the world continued to change, sometimes gently, sometimes with sudden shifts. Human societies blossomed across continents, carried ideas along trade routes, built monuments that touched the sky, and developed philosophies, mathematics, and early sciences. Yet for all the beauty and wisdom these civilizations created, life remained tethered to the slow rhythms of muscle, wind, and water. Work was powered by the strength of people and animals, by flowing rivers turning wooden wheels, or by sails capturing the breath of the air. Then, only a few centuries ago, a blink in Earth's long memory, everything changed. In small workshops and crowded towns, humans discovered how to harness the power of steam. Steam engines turned heat into movement, and movement into industry. Machines replaced hand labour. Goods that once took weeks to craft could now be produced in a fraction of the time. Mills rose along rivers. Smokestacks reached toward the sky. Railways stitched across the land like threads pulled through cloth. Ships powered by coal crossed oceans without waiting for favourable winds. This new power transformed landscapes. Forests were cut to feed furnaces or fuel expansion. Mines opened, reaching deep into the earth to extract metals and coal that could be burned or forged. Towns grew quickly around centres of production, becoming sprawling cities where thousands, then millions of people lived and worked. Streets filled with the sounds of wheels grinding against stone, engines whirring, voices echoing between narrow buildings, and factory whistles marking the passage of time. Night no longer meant rest. Gas lamps illuminated streets, extending human activity into hours once held by darkness. With this industrial growth came consequences. Rivers, once clear, carried waste from factories. Air thickened with soot and smoke. Forests shrank. Wildlife retreated. Soil grew tired under constant cultivation. Yet at the same time, the New Age brought opportunities for learning, exploration, medicine, and connection. Scientific discoveries accelerated. People began to understand the workings of electricity, magnetism, and chemistry. Diseases that had plagued humanity for centuries began to yield to hygiene, vaccines, and new treatments. Life expectancy slowly rose, and the world felt both larger and smaller at once. But human progress, like Earth's history, moved in uneven waves. The same technologies that powered factories also powered conflict. Nations expanded their ambitions, resources became causes for tension, and as industrial capabilities grew, so did the scale of human struggle. The 20th century opened with rival empires, contested borders, and a sense of uncertainty echoing across continents. When conflict erupted, the world entered a period of suffering that reshaped everything. The First Global War brought mechanized armies marching across landscapes transformed by trenches and explosions. Fields that once grew crops became scarred with deep lines, muddy and desolate. Forests burned, rivers filled with silt. The land itself carried the weight of conflict, and when peace came, it was fragile. 2 decades later, the world plunged into an even greater storm. Cities were leveled, skies glowed with the light of bombs. Entire regions were reshaped by destruction, or rebuilt afterward with hope and determination. Among the darkest turning points of this era was the discovery of how to release the energy held within the core of atoms. Instead of using this knowledge gently, some nations used it to create weapons of unprecedented power. The world witnessed a force so immense that it left deep scars, both in the places where it was used and in the collective memory of humanity. In the decades that followed, nations grappled with the uneasy truth that they now held the ability to harm not just each other, but the future of the planet. Yet even in the shadow of these threats, humanity continued to connect and rebuild. Technologies that once served war soon helped create peace, communication, and discovery. Radio waves carried voices across oceans. Television brought distant places into living rooms, and then, in the late 20th century, a new kind of connection emerged: the digital world. Computers, once the size of rooms, became smaller, faster, and more capable. They moved from laboratories into homes, offices, and eventually pockets. The internet bound information together in a web that circled the globe. A message written in one corner of the world could reach another almost instantly. Knowledge that once took lifetimes to gather could now travel at the speed of light. Entire cultures, ideas, and innovations mingled through screens and signals, making the world more interconnected than ever before. These connections transformed global trade as well. Goods travelled across oceans in enormous ships, then crossed continents by rail or road. Supply chains linked factories, farms, laboratories, and markets across vast distances. Cultural exchange followed. Foods, music, languages, and traditions blending in ways both beautiful and complex. Yet this interwoven world also created new challenges. Wealth accumulated unevenly, environmental pressures increased, consumption rose, and the planet felt the weight of human activity in its oceans, atmosphere, and forests. Pollution, once limited to cities and rivers near factories, spread across regions. The atmosphere warmed as heat-trapping gases increased. Forests were cut to make way for agriculture. Species disappeared as habitats shrank. The rapid growth that had once seemed like a triumph now carried consequences that could no longer be ignored. In response, new movements for conservation emerged. Forests were protected. Endangered animals were given safe havens. Renewable sources of energy were explored. Sunlight, wind, rivers, and the subtle warmth from beneath Earth's crust. If we could walk through one of the great cities of the modern world, we would see the contrast shaped by centuries of change. Towers of glass and metal rising from landscapes once carved by glaciers. Crowds crossing streets lit by electric lights. Vehicles humming softly over asphalt. Airplanes soaring overhead. Metal birds carrying people to destinations across the globe. Markets filled with foods from distant continents. Screens glowing with information, art, and messages from faraway friends. Human ingenuity has created marvels, but each marvel rests on the earth, drawing from its resources and shaping its future. Industry, war, and global connection reshape the planet in ways both inspiring and sobering. Humanity gained the power to build and the power to break. It unlocked comforts and complexities, creativity and responsibility. But beneath all this change, the Earth remained the same ancient planet, still turning, still waiting, still bearing the marks of every chapter written upon its surface. As we move deeper into the modern era, a new frontier begins to appear, not only in factories or cities, but in intelligence itself, and in the dream of leaving our planet to explore others. The next chapter is a story of minds, machines, and the expanding boundaries of possibility. As the digital world wove its threads ever deeper into daily life, a quiet shift began to unfold, one not driven by steam or steel, but by information, patterns, and thought. For the first time in Earth's long history, intelligence was emerging from circuits rather than cells. Machines could learn, reason, and adapt, not in the way humans do, with memories shaped by experience and emotion, but through patterns recognized in oceans of data. This new form of intelligence, built from logic shaped by human design, would soon transform everything from how we work to how we explore the universe. Artificial intelligence had humble beginnings. Early programs followed rigid instructions, step by careful step. But as computing power increased and algorithms became more flexible, machines began to learn from examples, adjusting their internal pathways in ways that echoed the faintest rhythm of biological learning. Eventually, these systems grew capable of recognizing faces, translating languages, guiding vehicles, and even generating new ideas. They became partners, sometimes assistants, sometimes advisors, sometimes quiet companions woven into the background of modern life. Yet as AI advanced, it raised gentle but important questions. How should such intelligence be used? Who should guide it? Could humans ensure that these systems reflected empathy, fairness, and wisdom rather than bias or manipulation? The rise of AI was not a story of fear or inevitability, but of responsibility, an invitation for humans to shape a world where machines enhance understanding rather than replace it. Carefully designed, AI could help diagnose illnesses, model climate patterns, accelerate scientific discovery, and make the world more connected and thoughtful. At the same time, another horizon was opening, the one above our heads. After centuries of dreaming about the stars, humans began to venture beyond Earth with growing confidence. The first satellites lifted quietly into orbit, orbiting like small metal moons. Soon, astronauts followed, floating in the sunlight above the blue curve of Earth. Space stations became laboratories suspended in the quiet of low orbit, places where humans studied life, physics, and the delicate balance of the body in weightlessness. In recent decades, this era of exploration deepened. Private companies joined national agencies, sending rockets upward with increasing frequency. Reusable boosters returned to land like gentle, guided pillars of fire, reducing the cost of spaceflight and making the dream of regular travel more realistic. The moon, once only a distant sphere of pale light, returned to human plans. Programs were developed to place astronauts on its surface once again, this time not for brief visits, but to build outposts where people could live, work, and learn in the silence of lunar nights. A small station called Gateway is being planned to orbit the moon like a celestial harbour, a stepping stone for missions beyond. From there, astronauts may one day travel deeper into space, to asteroids, to Mars, and perhaps even to the outer moons of gas giants. With each journey, humans would learn more about surviving in harsh environments, harvesting resources far from home, and building life where none existed before. Mars, with its cold deserts and thin atmosphere, has long captured human imagination. Robotic explorers have already trundled across its rust-red plains, studying rocks, dust storms, and ancient riverbeds that hint at a watery past. The dream of building shelters beneath its skies is still distant, yet not impossible. Such bases would require recycling every drop of water, growing food in carefully managed greenhouses, and protecting homes from radiation with layers of soil or ice. The settlers of Mars would become gardeners of a new world, tending life in a place where the environment is cold and unforgiving but rich with scientific promise. Beyond Mars lies an even broader canvas of possibility. Space telescopes peer into the dark, studying distant planets around other stars, worlds with oceans of methane, worlds locked tidally to their suns so that one side is forever day and the other forever night, and worlds that might hold hints of habitability. AI helps sift through the flood of data, finding patterns too subtle for the human eye to catch. Together, human curiosity and machine assistance expand our understanding of what home might mean in the vastness of space. Back on Earth, technology continued to reshape humanity itself. Advances in gene editing, described gently as tools that allow careful adjustments within the blueprint of life, opened new doors. These tools held the promise of healing inherited diseases, strengthening immune systems, and perhaps one day preventing certain illnesses altogether. But with such power came profound ethical questions. How should these tools be used? Who should decide? How could humanity ensure fairness and compassion in such choices? As with AI, the potential was vast, but so was the responsibility. Human identity itself began to stretch. People blended biological abilities with tools that extended sight, hearing, memory, and physical strength. Some imagined futures where humans might enhance their bodies to survive in new environments, thicker bones for low gravity, altered metabolism for colder climates, or even symbiotic systems that recycle water and air more efficiently. Others believed that human advancement would come through the merging of biology and technology, interfaces that allowed thought to flow seamlessly into devices or even into other minds. Yet even as the future expanded outward and inward, humanity remained tethered to Earth. Our roots, our stories, our sense of belonging all came from this planet. The technologies that allowed us to explore the Moon, Mars, or distant data patterns were born from Earth's rich history of creativity and challenge. AI, space travel, and genetic understanding were not escapes from humanity, but expressions of its oldest traits: curiosity, adaptability, and the desire to reach beyond horizons, whether physical or abstract. If we stood in a modern city today and looked upward, we might see satellites gliding silently across the night. We might hold a small device in our hands that contains more knowledge than entire ancient libraries. We might read messages from across the world with the tap of a finger. Our lives are wrapped in layers of technology, each one shaped by the choices of countless people over generations. And as we move toward a future filled with both promise and uncertainty, one truth remains: every choice we make echoes across the planet and through time. This chapter of human history, defined by intelligence that grows beyond biology, by journeys that leave the cradle of the Earth, and by tools that shape life at its foundations, marks a moment of profound change. It asks us not only what we can do, but who we want to be. And as we listen to the soft hum of machines, the whisper of data, or the distant call of the stars, we find ourselves standing at the threshold of possibilities that stretch far beyond anything our ancestors could have imagined. Across the long story of our planet, life has risen, vanished, and risen again. Continents have drifted like slow-moving rafts. Oceans have opened and closed. Mountains have lifted toward the sky only to sink back into dust. And through all these changes, Earth has remained a patient host, warm enough, stable enough, and gentle enough for life to flourish. But even the most accommodating worlds have lifespans. Just as living beings age, stars do as well. And Earth's fate is tied quietly but firmly to the life of the sun. If we could step far into the future, far beyond the years of nations and civilizations, beyond even the span of species, we would find a world still spinning beneath the same star, but with a subtly shifting glow. The sun changes slowly as it fuses hydrogen into helium at its core. This process makes the sun grow just a little brighter with each passing 100 million years. The change is so gradual that no single generation could ever notice it. Yet across immense stretches of time, the accumulated warmth alters the balance of the planet. About 1 billion years into the future, a number so large it stretches beyond imagination, the sun's added brightness will warm Earth enough to evaporate more water into the air. The air will hold this moisture like a thick blanket, trapping heat and causing the oceans to slowly shrink. Rivers will weaken, forests will thin. The planet will not change all at once, it will shift in long, slow sighs. But eventually, the great cycles of clouds and rain that sustained life for billions of years will begin to falter. By this time, complex life as we know it will struggle to survive outside the shrinking pockets of cooler climates. As the sun continues to brighten, the oceans will evaporate further. In time, Earth may begin to resemble a world of salt flats, cracked riverbeds, and winds that carry fine dust over lands that once held forests and lakes. The oceans, the vast blue expanses that cradle the planet today, will become shallow basins shrinking beneath a hotter sky. Even then, the planet will remain beautiful in its own way. Sunsets may glow with deeper reds, and the horizon may shimmer with dry heat. But the world will no longer be a home for the richness of life it once nurtured. Countless ages later, as the sun exhausts its supply of hydrogen, a deeper transformation begins. The core contracts, the outer layers swell, and the sun expands into a red giant, a star much larger and more luminous than the one we know today. Its outer atmosphere will balloon outward until it reaches toward the orbits of the inner planets. Mercury will be the first to vanish, swallowed quietly into the star. Venus may follow soon after. Whether Earth is engulfed remains uncertain. Some models suggest the Sun's expansion will consume it. Others suggest that as the Sun loses mass, Earth's orbit may drift outward just enough to avoid being swallowed. But survival, in this case, is a gentler form of ending. Even if the planet is not consumed, it will be scorched to a silent, lifeless sphere, a world of molten rock and empty plains. Its atmosphere will have long since burned away into space. No ocean will shimmer on its surface. No wind will carry scents of forests. No creature will walk beneath its sky. Earth will become like many other planets, a silent relic orbiting an aging star. Eventually the Sun will reach its limit. Its outer layers will peel away into space, forming a glowing shell of gas, a delicate, expanding bubble shaped by solar winds. This glowing structure, known in astronomy as a planetary nebula, will drift outward like a cosmic lantern fading in the dark. At the centre, the core of the Sun will remain as a white dwarf, a small, dense, and incredibly hot object no larger than Earth itself, shining with the leftover heat of a star that once warmed a thriving world. If Earth survives to orbit this white dwarf, it will do so as a cold, dark remnant. Its surface will freeze, its rocks will crack from the cold, and the last traces of its ancient oceans will lie frozen beneath dust that has settled for eons. There will be no sound, only the silent pull of gravity, holding the planet in place around a faint, fading star. And yet, even in this quiet ending, there is a kind of continuity. The atoms that once formed forests, animals, oceans, and even people will not vanish. They will be carried outward by winds, broken apart by time, and eventually drift into the interstellar medium. There, mixed with clouds of gas and dust, they will become part of new structures, perhaps new stars, new planets, and maybe even new homes for life. Every atom in our bodies has already lived inside stars before. In the far future, they will return to that endless cycle. If we imagine this future from the perspective of Earth itself, the story becomes strangely poetic. A planet born from stardust will eventually return to stardust. A world that nurtured life for billions of years will give its materials back to the cosmos, joining a vast river of creation that flows across the galaxy. Nothing truly disappears. It simply changes form. For us, living in the small bright window when Earth is at its most welcoming, this distant ending is not something to fear. Rather, it is a reminder of how precious the present is. Life exists here not because it was guaranteed, but because a long chain of cosmic events created just the right conditions. Our world is a rare moment of warmth and complexity in a universe where most places are silent and cold. Earth has given us air to breathe, water to drink, land to grow food, and the beauty of forests, oceans, mountains, and skies. It has given us the chance to love, to learn, to imagine, and to build. And though its story will one day close, we are alive within its most extraordinary chapter. The responsibility we carry is gentle but profound, to care for this world while it is still full of life, to honour the fragile balance that allows us to be here, to remember that we are temporary stewards of a planet that has nurtured countless generations before us and deserves to thrive for countless generations to come. When the night grows quiet and we look upward at the stars, we're seeing the environments where new stories are already beginning, the places where the materials of our planet will someday drift. And in that gentle cosmic exchange, Earth's final chapter becomes not an ending, but a continuation into the broader story of the universe.